Hi everyone, it's Ms. Lopez. In this activity, we are going to be looking at data to answer the question, does the ratio of boys to girls in AP Biology match the ratio at Round Rock High School? And in this type of activity, we're going to use a chi-square to help us analyze the data. We do acknowledge that there's going to be some variation. There's going to be a little bit of randomness as far as how, the number of boys to girls in AP Bio doesn't quite match the ratio, the number of boys and girls at Round Rock High School. But we want to use chi-squares to help us understand, is that true or is there something else going on? So in order to do that, we're going to need to use a null hypothesis to help us understand and predict what those numbers should be. So your null hypothesis is looking at the ratio of boys and girls in AP Bio matching the ratio of boys and girls in Round Rock High School there. Your alternative hypothesis will be the opposite to that. So it's saying that the ratio of boys to girls does not match the ratio of boys to girls at Round Rock High School. Now, in order to do this, we are going to need some information. Obviously, we're going to need to know what the ratio of boys to girls in AP Biology is. But then we're also going to need to know, well, what's the ratio at Round Rock High School? And then we can use chi-squares to figure out, even though there's some variation to it, there's going to be some randomness in terms of how many boys and girls are in AP Bio. Is it still close enough to that ratio at Round Rock High School? And so that's what we're going to be doing today. And that's what we're going to be comparing. Now, in order to do that, we do need to know some information. We need to know how many boys/girls there are in AP Biology. And then we're also going to need to know, well, what is that ratio at Round Rock High School? And so what we're going to do is we are going to first talk about what the data is. We're going to look at how to calculate those expected values, and then we'll fill out our chi-square table. All right, so I went and I looked up this information based on a couple of things. So number one, I looked up based on the hand lab that you guys did where you submitted that information, how many boys versus how many girls there were in AP Biology based on that XXXY chromosome. So what I'm gonna do is I'm gonna go ahead and put XX and XY, and I'm gonna give you that information. First, we're going to look at in AP Biology. Okay, so in AP Biology, we have 210 female and 109 male. Again, this is based on the presence of that Y chromosome. Unfortunately for Round Rock High School, I was not able to get the actual numbers. Instead, what I was able to get are percentages. So I'm going to give you the percentages for Round Rock High School, and then what we're going to have to do is we're going to have to figure out what would be the actual number of students based on the population in that AP Biology. So at Round Rock High School, there are 47% XX and 53% that are XY. And so we can't compare percentages to actual numbers. So what we're going to have to do is take this value of students at Round Rock High School, and we're going to figure out, well, what would that number be for our population? Now, to do that, what you're going to do is you are going to get your total. So the total number of students, both in AP Biology, so 210 plus 109, 210 plus 109 is 319 students. Now, based on the percentages at Round Rock High School, we are going to figure out if the total number of students is 310 total students in AP Biology, and they follow this ratio. If they follow this ratio, we're going to figure out what those numbers are. So based on those 319 students in AP Biology, 47% of them should be XX, 53% of them should be XY. The number that you see here, these are the actual number, what we call the observed number of students in that class. But what they should be of this total population, it should be 47% XX, 53% XY. So I'm going to go ahead and do that conversion. And the way that you do that, let me erase this percent sign here. The way that you figure out what your expected value is you take your total and you multiply it by the percentages. So I would take 319 times 0.47. And that will give you the number of students that we are expecting. Likewise, I would take 0.53, multiply it by 319, and that's how many we would be expecting in AP Biology. So 47 times 319 is 149.93. And it's okay to have a decimal as your expected value. That's perfectly fine. Likewise, I'm going to take 0.53 and multiply it by 319. And I get 169.07. Again, these are expected values, so it's okay to have that decimal. So this is what we would expect it to be: 149.93 XX, 169.07 for XY. The actual number of students based on the hand lab was 210 and 109. So we understand and we acknowledge that there's going to be a little bit of fluctuation. There's going to be a little bit of randomness when it comes to the actual number of students. But the question is that variation that we see, is the difference between 210 and 149 within an acceptable limit of randomness? And that's what our chi-square is going to tell us. So let's take a look at that. All right, so what you see here is the chi-square table, and I've already filled it out for you. I've taken the observed values that were given to us on the previous page. Those are the number of students actually in AP Biology according to the form that y'all filled out. And then I've also filled in the expected values. And we got those expected values by multiplying the percentages based from Round Rock High School times the total number of students that are in AP Biology. Then we take observed, so the rest of this right here is part of the chi-square process. This is what you need to do in order to calculate your chi-square. You take the observed minus the expected, and notice that sometimes the number comes out negative. That's okay. However, when you take the observed minus the expected and you square that, so look at your parentheses here. Even if this value comes out to negative, you're still going to square it. So a negative times a negative becomes positive. So there should be no negative numbers here. Then we're going to take the observed minus the expected squared. We're going to take this value and divide it by the expected, which is over here. And that's what I've already done for you. And then at the end, what you do is you are going to add up this column, add these two numbers up, and you get what is known as your chi-square. Don't take the square root of it, don't square it, just add those two numbers up, and that is your chi-square value. You're going to take that chi-square, but what does it mean? How do we interpret it? We're going to take that and use our formula sheet to help us interpret the results. So we know what the chi-square is, but the question is, do we reject the null hypothesis or do we accept it? Is this within an acceptable limit of just, it was random that 210 are female and 109 are male instead of these perfect numbers that we were expecting here? But is that just due to randomness? And so that's what our data table is going to help us to interpret. All right, so here is your data table. College Board will give you the same data table on the day of the AP exam, and you wrote you the chi-square. Now in AP Biology, we always start by using a p-value of 0.05. That means that's the row we're going to look at. Unless they tell you, they specify to use 0.01, you always use 0.05. Then what you do next is you figure out your degrees of freedom. And your degrees of freedom are always equal to the number of possibilities minus 1. So the number of possibilities are XX, XY. And so we take 2 minus 1. And so our degrees of freedom are going to be 1. And where the two intersect, that green area that you guys see right here, where the two intersect, that is our value we're going to compare our chi-square to. Okay, so 3.84. If our chi-square is larger than this value, then we reject the null hypothesis. If our chi-square is lower than this value, then we fail to reject the null hypothesis. So let's take a look now, and whoa, that is a big, big difference. It's the chi-square is much higher than that critical value we were looking at. So when you write your conclusion, you start by saying whether or not you reject or you fail to reject the null hypothesis. And in this case, we're going to reject it. We reject the null hypothesis that the ratio of boys to girls let's just do it like this. In AP Bio, match the ratio of boys to girls at Round Rock High School. Okay, so first we reject that null hypothesis. And we've got to back it up with evidence. Why are we rejecting it? And the reason we are rejecting it is because the chi-square value of 45.4 is larger than the critical value of 3.84 at 1 degree of freedom. Boom. So we've rejected the null hypothesis. We have evidence to support the alternative hypothesis. As you can see that chi-square is much larger than that critical value. But when you're writing your conclusions for chi-squares, you want to talk about whether or not you reject the null hypothesis or you fail to reject it. And then you want to back it up with your numbers. So this is the chi-square that we actually calculated, okay? And we are declaring that it is larger than the critical value we looked up on that table, and that critical value was 3.84 because we were using 1 degree of freedom, okay? Now, this doesn't explain why there are more girls than boys in AP Biology. All we know is that the number of students in AP Biology who are XX versus XY, that number does not match what we would predict it based on the ratios of boys to girls at Round Rock High School. Thank you guys so much for watching. I hope this video was helpful. See y'all later.